actually very much in line with pre-cal. They're doing the same thing when it comes to this kind of stuff. So solving quadratic equations, when you're asked to solve, I'm going to do that in caps here. This is in page 20, right? I said that. If you're asked to solve a quadratic, you need to determine, find, or /find the x-intercepts. So note that the x-intercepts or intercept, right? That's why I'm just going to go in brackets like that. It could also be none, right? But it's the same thing as the roots. The root or the roots, it's the same thing as zeros. And that is the same thing as solutions. So I just thought of that now because sometimes it says, hey, what are the solutions to this function? They're all asking for the same thing, guys. Find the x-intercepts. I can say find the roots, find the zeros, find the solutions. All mean the exact same thing. In fact, if you grab your calculator and you go second trace, you see that second option that I don't really use? That one is specifically to find the x-intercepts. I just found a different way of doing it, right? The way I show you y2 is equal to 0, you have two equations, and then it's just enter, enter, enter. This one is a little bit trickier to use. It may be that your grade 12 teacher uses that one. So I think I'm going to show you how to use that one just so you know it can be done that way. Okay? So stay tuned. So for all of these, if you're trying to find the x-intercept, you must know that in any of these cases, y is equal to x-intercept. Your point touches the x-axis, y is going to be 0, right? If there is ever a y, we know that that is 0 because, hey, x-intercepts, after all, right? Since an x-intercept will always look like this, a number followed by 0, right? And this is your y. So therefore, y is 0 whenever you want to do that. There are two methods of solving quadratics. Using the quadratic formula, this is by hand. And you must use the quadratic formula if I require you to do that. And method 2 is variation. So this is using the TI-84. Okay, so those are your options there. They're all essentially doing the same thing, but the quadratic formula is what I'm going to start with. So given this general form, right? If something is in general form, so we might have to do some arithmetic, some algebra to make it look like this. We can find the roots. Notice that I say roots, right? Which you know means x-intercepts, solution, all of that. Using the following formula. So here it is. Make sure you have it exactly the way I write it. And I'm actually going to make sure you won't have an excuse to have this wrong. So basically, you go x equals like that, and then just make a long line like this. You may use pencil first, and then you do the red line with your color of your choice, just in case you need more space. But I'm going to say you will have to take negative b, like that, plus or minus square root of, it's a long root, b squared minus 4 times a times c. So the root is the whole thing like that. All of that divided by 2 times a. So this formula should be on your study sheet by the end of today. I would say have that on there. So you probably have heard me say that, and if even in grade 12, I tell students if I highlight a box, hint, hint, right? Have that on your study sheet. Very, very important. So why am I putting the red line there? A lot of times students, for some reason, that line shrinks and it's just under the root here. But really what needs to happen is the top, you need to compute whatever is at the top first and then divide at the end. That's like the very last thing you'll be doing. Okay. That's why I have the red line to indicate, no, it's the whole thing. All of this up top gets divided by 2a at the end. And another thing I will tell you is that your textbook, or if you Google this, the formulas will not have brackets. They will not have these variables in brackets, but you should know whenever you do get a formula, it's basically saying, hey, like you insert whatever b is into here, into this bracket, and then you apply that negative to whatever is in here, right? So you need to make sure you get that right. This part right here, this part in here is called the discriminant. So I'll call that discriminant, right? Like that chunk that is inside the root is discriminant. And that tells us a bunch of things. So essentially, if b squared minus 4ac, which is inside the root, is positive, then you will have, for sure, you're guaranteed to have, you have two roots or solutions. Guaranteed. If the discriminant is 0, right, obviously equals to 0. If whatever is in the root, you compute it and you get a 0, then you will have one root, one solution. And if it's negative, you will have no roots, no solutions. Okay, so that is, it basically tells you that, right, in this scenario, you're guaranteed that the parabola is going to cross the x-axis twice. It's going to cross it once. It's exactly where the vertex is. It's not going to cross the x-axis, right? So it's a different way of looking at it without graphing, right? You're not graphing here, you're just plugging in numbers. Let's keep going and do one example using this formula right here. Okay. Remember, it has to be in general form. It has to be in general form. You got to get rid of brackets. You might have to do some multiplying out and stuff like that, foiling, depending on the situation. Okay. So here it says, straight up, it says quadratic formula, right? It says solve the following using the quadratic formula. Solve, right? Find x-intercepts. Right, that's the thought you should be having there. Oh yeah, I know what solving means. I know what finding the root means. I know what that is. It's just simply finding the x-intercepts, right? So get comfortable with that. And I have to use the quadratic formula, which means, here it is, one more time. Get used to writing this out because you're gonna need it. 4 times a times c, all of that divided by 2 times a. So that's the thought you're having. What a thought, eh? No, Mr. Erickson, that's definitely not what I'm thinking about right now. Not at all. All right, that's okay. I'm thinking about how I'm going to post the picture. That's all I'm thinking about. So here you have the equation, and note that y is equal to 0 since we are finding x-intercepts. So when you have a y in there, don't panic, just turn it into 0, right? So we'll just go, therefore 0 is equal to 3x squared plus 3x minus 3. This is the easiest case scenario ever. You already have it in general form. It's the right, like you have 0 on one side, you have x squared, x, and constant, no brackets. So what we know here is that a is equal to 3, positive, b is equal to 3, positive, c is equal to negative 3. So make sure you get the sign and everything with you. And because we're already thinking of the formula, I'm not going to write it down again. Okay, so x is equal to, it calls for negative b. So we're going to go negative 3 plus or minus square root of b squared minus 4 times a times c. Watch out, c is negative. Watch out. All of that divided by 2 times, bless you, 2 times 3. Lots of 3's. That's confusing, Mr. Dirksen. Why did you pick 3's? There'll be more examples coming down the road, but the negative c is very important there. Okay, so we clean it up. Should I, you know what, why not? It doesn't hurt, right? I'm just going to say that this a value only shows up here and here, right? A shows up here and here. Look back at the formula, right? A is over there and here. So these two values, I used A for that. I'm going to use orange for B. Shows up here and here. And I'm going to use pink. Okay. Color coded. Now we know what to do. So here you got to be careful. Right? Don't plug everything in at the same time. I'm going to clean this up. Negative times positive 3 is just a negative 3. Plus or minus root. Grab your calculators. I will show you the fail-safe method of doing that. Inserting it exactly the way you see it there. So bracket 3, close bracket squared, minus 4 times 3 times negative 3. You heard me right. Negative 3, right? This is a negative. So you have to use the negative button for that one. Because when things, so minus here, and this is a negative. So I should probably say use this one. Use that button there. Because when we're multiplying a bunch of things, if you bracket it and you want to multiply it, you got to use the negative 3 in that case. So then you hit enter and you get 45. So all of that inside the root is just down to 45. The denominator, 2 times 3, I hope, right? We don't need a calculator for that. That's just 6. And I'll make a note here. So we're almost done here. We're close to the shore, right? So I will just make a note. Note discriminant is positive. Therefore, how many roots? You'll have 2 roots. two solutions. So this part right here is positive. The value itself doesn't matter. If it's positive, you're gonna have more than one root. Okay? And this is where I branch off. Let me rewrite it one more time because or no, maybe I'll just leave it like that. I'll just say it's gonna get too messy, so I will rewrite it. My bad. Just because of this note, it kind of, so let's do it one more time. I need to make sure this one looks as clean as possible. So you branch off. You basically will branch off and say that the first root, and I call it x sub 1, you will find by going -3, and you probably were wondering what's up with the plus or minus, right? So one of the roots will be found by going plus root of 45 divided by 6, and the other root will be found by going x2 is -3 minus, right? That's where the minus comes in, minus root of 45 divided by 6. So these answers are going to give you your roots. So let's go like that. And I'll show you a little cheap maybe, but you got to go -3, right? -3 plus second x2 opens the root 45. I hit enter at that point. I figure out what the numerator is first. So I hit enter, and then I divide by 6, right? I go divide by 6. So you get 0.62, right? So technically what you found is 0.620, right? That's one of the x-intercepts that you found. I'm fine either way. But you're really fine, you found that x-intercept. You're with me, right? Watch what I do next. This is a little shortcut. I copy, you know how I went -3 plus 45? I copy that down and I just change that to a minus, right? And then hit enter again. And you cannot forget to divide by 6, right? Don't forget that. So I'm going to go divide it by 6. That's -1.62, which is really -1.620. That's the x-intercept you just found. So there are your two roots, your two x-intercepts, your two solutions. You solve the quadratic using the quadratic formula. Okay, so Mr. Dirksen, could I have just typed this in, right? Like go 3x squared plus 3x minus 3. Could I have done it that way? I'm going to go zoom standard. There it is. You can tell there are two roots. If I go find the intersects, that's -1.62. That's the one we found here. Second trace 5. You go find the other one, enter, enter, enter. 0.62 if you round that one as well. Okay, so you're doing the same thing, but this is by hand, not using. Can I verify with this, Mr. Dirksen, on a test if I have time? Sure, you can verify. Type this in. You should get the same answers. If not, something went wrong, right? Something went wrong. And it's basically like be careful how you enter it. And then you slowly move through it, but don't. And for some reason, I can't pinpoint. Students leave this one blank sometimes. This question. So I'm wondering, did you not write down the quadratic formula on your study sheet? Is that right? Like that's my only conclusion there. So have that quadratic formula down. It doesn't happen very often, but I have had it from time to time. Okay, let's do one where we have to manipulate a little bit. We have to clean it up. So this one right here. So what I will suggest here is I'll make a note for you. Bring all terms over to one side. This is what I would recommend. Okay, and you do it the way you see fit. Okay, but I will make another note. Terms switch signs when they come over. Does that mean anything to you? If you have a negative 3x on the right side of the equation and you bring it over the equal sign, it changes signs. I don't know if you've ever thought of it that way, because you're adding 3 to both sides in that case. So this is what I'm proposing here. For example, I will circle my x squared term. So there's an x squared there, and there's an x squared there. Notice the equal sign, right? Notice where's the equal sign? It's right there. So I go 8x squared. This one is already on the left side. I tend to bring everything over to the left side. So the 3x squared comes over, subtract. So the 8x squared is already there. The 3x squared was positive on the right-hand side. You bring it over, subtract. Now I focus on the x's. Okay. So the 5x is already positive. So whatever sign it has, it keeps it. But then you go over to this side, and the 4x, when it crosses the equal sign to this side, it actually goes positive. Positive 4x. And last but not least, you tackle the constants, right? Like there's only a 7 here, there's no constant on this side. So basically just go plus 7. And if you think about it, if the 3x came over and the 4x is over, then there's nothing left on this side, so it's just equal to 0. That's exactly how you want it. You want one side equal to 0. Okay. And then clean it up. 8x squared minus 3x squared is 5x squared. 5x plus 4x is 9x. Plus 7 is equal to 0. So this would usually be on a test be 1 mark, cleaning it up. 1 mark to get it to look like this. You combined like terms. That's what you were doing. And so A is 5, positive. I like you to identify this. Everything is positive, right? And now I just plug in and go, right? So this is my formula. X is equal to negative b plus or minus b squared minus 4 times a times c. All positive, right? So there, you don't have to worry about any of that. All of that divided by 2 times a. Now clean it up. Negative times positive 9 is just negative 9, plus or minus. Let's figure out the root part. So if you want to make sure you have this right, just type it in exactly the way I have it here. Technically, because they're all positive, in this case you didn't need brackets, but that's what you get, negative 59. Uh-oh. I either made a mistake or no roots. Okay. That's what's happening here. I'm going to go over 2 times 5, which is 10. And at this point, I want you to stop and say no roots, but explain why. Discriminant is negative, therefore no roots, no solution. This quadratic cannot be solved. It will never cross the x-axis. Does it make sense? You just need to practice, guys. Honestly, like I'm gonna give you some ugly ones. You're gonna have to practice that, right? You're gonna have to clean that up. Why don't you do the ugly ones and give us the easy ones? I will probably do at least one more ugly one, if not today, tomorrow. So last one here that I'm going to do, and then I'm going to hand you over to try at least one. Again, clean it up. So in this case, I don't like brackets. It's not in general form. So multiply, right? Multiply, right? So 3x times x would be 3x squared. 3x times 2 is 6x, and that's equal to -3. And one more step left. Like this one is actually not too bad, right? You just have to bring the -3 over to the left-hand side. Question? Yeah, go ahead. What if I bring everything over to the right side? Go ahead. You're going to get the same answer as me. Except for the signs are going to be different, right? Like if you bring this one over here and this one over here, they're both going to be negative in this case on the right side. But your final answer will be exactly the same, and I have no problems with you doing that, right? So whatever you want to do, as long as you're consistent, right? 3x squared plus 6x, nothing changes. The 3 comes over adding, okay? 3 comes over adding, and that's now equal to 0 on that side. So I think I'm going to give this over to you at this point. You do the rest. You figure out, using the quadratic formula, what the x-intercepts, or if there even is one, you figure that one out. And then we're going to shift gears a little bit. Still doing the same thing, just using a different method. So back to 21. Back to 21. So we cleaned this up, we rewrote it, and so we can just go ahead and, oh, I tell you to do this, right? So that's probably a good idea. Thanks, Caitlin, for finding my mistake. I think others found it too. Okay. X is minus -b plus or minus root of b squared minus 4 times a times c, 2 times a, like that. And then you find out that the discriminant is discriminant happens to be 0. And you can see, right, 4 times 3 is 12, times 3 is 36, and this is also 36. So you can kind of just do a mental math check there. -6 plus or minus root of 0 over 6, right? Discriminant is 0, therefore 1 root. Okay, you can make that note there. So basically you're just down to -6. Plus 0 minus 0 won't change anything. So it's just -6 over 6, which is -1. Okay, so it's -1, 0. You just have 1 root. So that's where it's at. Too bad I forgot to change that sign on yours. Too bad. So anyways, you've got 3 examples there. I'm going to tell you to go and to 23, and I'm just going to recant my answers. What was it again? 0.62 and negative 1.620. Yeah, you got those? Those are the official answers again. So my bad. Messed that one up. But good thing I have good students that hold me accountable. They find my mistakes, right? So I can't call this week perfect anymore. So how else can we solve quadratics? This is using the quadratic formula. But go to 22. This one is going to be faster because you're going to be able to use your graphing calculator again. Okay. So go to page 22, graphing method. You're still doing the same thing here, but we're finding the x-intercepts if possible, right? Note that if lines do not touch, there is no x-intercept. So I'm going to highlight that because you will soon know what I mean. So two options. This is on page 22. Option 1, you let y equals 0 as before, nothing changes. Rewrite the equation into general form, nothing changes. You did this for quadratic formula as well. And then we enter the left-hand side into y1, the right-hand side into y2, and then we use second trace 5 to find any and all x-intercepts. Okay. This is intersect, right? In case you're right, we just find intersection between essentially y2 is equal to 0. One of them will be 0, and one will be the quadratic. So you're essentially finding the x-intercepts just like before. But what's different is you might have to do some rewriting. That's what's different. Okay. And then option 2, which could be faster, but sometimes it also is a bit more complicated to find on your screen. We let y equals 0 if present still. But watch this. You enter the left-hand side into y1 and the right-hand side into y2. There is no rewriting necessary here. That's why option 2, I will never make you do one over the other when it's graphing. You choose which one you want to find, how you want to do it. And then you find second trace 5 to find any and all x-intercepts. Watch. Since you're finding the x-intercepts, you must state the answer like this. Okay? So I'll give you an example what's going to happen. When you do it, when you use this method, you may have a quadratic and another quadratic like this. It might be that there's two curves because either side is a curve. So this method deals with those two curves. So you're going to have to find the intersection there. And I'm just making this up, okay? So let's say you find that this is -3, 7. And this one right here is 2, 10, let's say. You found the intersections. They're usually going to be ugly decimals, right? But let's say you find that this is not correct. You have to state it like this. -3, 0 and 2, 0. Like, make sure, right? Y is equal to 0. So watch out for that. Only state the x values of the intersections you're finding. So there. That's pretty gross, eh? That's my spit right there. You can all see it. Anyways, I got too excited. -3 and 2, right? So you got to make sure you have a 0 here. Whereas if you use the first option, if you rewrite it, you're actually going to find, like it's actually going to be, let's say this is your curve, it could be pointing up or down. You're already going to find the x-intercepts using the first method. So you don't, whatever, when you find the intersect between y2 is equal to 0 and the curve, that you're done. You don't have to worry about not mentioning the y values. So this is the main difference. Here you're going to have two curves. Here you're just going to have one, and you just go ahead and find the x-intercepts as before. Okay, let's do this. Let's have fun with it. I'm going to use both methods for you here. You ready? So we're going to do option 1. Rewrite. Rewrite. So we need to do a little bit of cleanup here. So watch what I'm going to do. 32x squared minus 15x plus 50. I can't touch anything on this side yet because I need to FOIL it out. I'm going to zoom into that part here. There we go. So I'm just going to go ahead and multiply the 2 out throughout the whole thing. So that ends up being 12x squared plus 2 times 125 is 250x. 2 times 75 is 150. So we're closer. Let me focus here one more time. There we go. And so now I'm bringing stuff over. So I'm going to circle the x squares. So it's 32x squared minus 12x squared. I'm going to triangle like this. And so it's negative 15x. The 250 comes over the equal sign, subtracting. And then there's the plus 50. And the 150 on the other side comes over subtracting. It's equal to 0. Your teachers in the past may have done, hey, you want to get rid of the 250 here, subtract 250 from both sides, cancels this out. Watch this, you end up with a negative 250 on the left side by doing that. So we're doing the same thing, nothing changes. So let's clean this up. 32x squared and minus 12x squared is 20x squared. Negatives add here, right? You combine negatives, that's negative 265x. And this is going to be negative 100. And that is equal to 0. And here you're ready to do the y1, y2 thing. That's why I told you, hey, let's put y2, make y2 equal to 0. It's because of this exact concept here. We're basically solving by graphing. We're solving for the x-intercepts. So grab your calculator, because these will be a bit of a challenge to find on your calculator. That is the tricky part. So you're going to have to use your knowledge of quadratics. Hey, what's the a value? It's positive. It's narrow. It's pointing up. My y-intercept is negative 100. All those things are going to come into play here. So I'm going to zoom out a bit. Let's do that. Let's go ahead and enter it. You need to kind of struggle through this a little bit. 20x squared minus 265x minus 100. A standard window is probably not going to be the greatest, but I'm just going to go ahead and graph this thing. Oh, I saw one leg there, right? Saw one leg whipping down here. So what I'm going to do for now is I'm going to go y min. I'm going to go below 100 because I know my y-intercept is negative 100, so I know that's going to keep going down a bit more. So y min, I'm going to change it to negative 120 or so. Let's see if that works. Still not. Anybody try Zoom Fit? Did you try it? It worked? Caitlin says Zoom Fit works. I'm gonna join the club. Let's get fit. Join the Fit Club. Hey, that works pretty good. Zoom Fit did the trick. I want to see more of this arm here. So X max, expand this way. I'm gonna go 50. Why 50, Mr. Dixon? I don't know. It's like picking your 649 number sometimes. Okay. So there you go. That's a pretty good window right there. We need to find the x-intercepts, right? So we're going to go, I'm going to tell you here, second, trace, intersect, and let's go to town. Second, trace, intersect. Let's find that one. So enter, enter, enter. Oops, one too many enters there. So that's 1362, 0. Then I repeat the process. Second, trace 5. Now I'm going to go over to the other one. You got to get to the one that's closer. That's the one your calculator is going to find. Now I'm closer to the other one. So enter, enter, enter. And I get negative 0.37. Negative 0.37. 0. Boom. You found it. Could you have used the quadratic formula? Yes, you should have had the exact same answer using the quadratic formula. I will make a note here. Used Zoom Fit. Right? I used Zoom Fit and I made some adjustments. The power of Zoom Fit, right? And now option 2. Right beside it. It's going to be a lot less writing. So watch what I'm going to do. I'm going to copy this one here. 32x squared minus 15x plus 50 is equal to 6x squared plus 125x plus 75. So you choose your method. You just have to show me what you've done. For example, this is all the work that I would have wanted to see if you chose option 1. Option 2, you'd literally just, as is, you put the left-hand side into y1, and you put the right-hand side into y2. That's it. Exactly the way you see it. That's key. So I want you to try that. And I think Zoom Fit is going to be our friend here again. So let's go ahead, 32x squared minus 15, oops. Both of them are going to be parabolas, right? Think about it. An x squared, so this equation is a parabola, and this one has an x squared, so both of them are parabolas. Both of them are pointing up, right? So it's something to keep in mind here as I work through it. So none of the stuff we've learned up until now is going away, right? Everything is connected. Everything goes in sync. I just can't do it all in one shot, right? So I'm just going to double check real quick. Yep. Yep. So now I'm going to hit graph. I have a feeling that it's, oh, pretty good. Pretty good. I see both curves. You need to see where they cross. So in my case, all I would have to do is increase my Y max a little bit. So window, Y max, I'm going to go 10,000. Why 10,000? I don't know. Just go 10,000. Boom. You see that they cross. It crosses once here, and one's there. Oh, question. One more thing before I come up. Zoom fit. Let's just try it. Zoom fit. Zoom. Oops, I go the other way. Zoom fit. Let's see what it does. It's not bad, but it's harder to see. In which case you might want to use zoom in. It's like, I don't know what's happening here, but I'm going to investigate somewhere in that neighborhood right there. Oh, okay, I can see it crossing twice. Right? So go ahead and find it. Go second trace. Okay, one more thing. Just focus on the intersections when you do it this method, right? If you don't see the whole thing, if you can see where they cross, you're good, okay? So I'm going to go second trace 5. I'm going to go closer to this one. Enter, enter, enter. Negative 0.37, which matches that one. And do not write down 59. Actually, that's what I wanted to do here. Negative 0.37, 59, 82. Let's do this together. Right? And the other one, second trace 5. Right? 10, 10, 10. That one is 13.62, 5,779.43. But those would be wrong answers, right? I would have to take off marks here. So you want to say negative 0.370, right? And 13.620. So you have to make sure like that this is the case here. This is wrong, okay? If you state it like that, that would be wrong, okay? And I'm gonna, this is basically solving quadratics. Quadratic formula, graphing method, you have to practice. And so here's where I'm gonna send you to do your homework. So I'm just gonna post everything from page 23 all the way to 25. No, I'm going to go 23 to 25, and if you want more, 26 to 28. So here it is. Write it down at the bottom. 23 to 25. 23 we already did. You just have to do it the graphing method way yet, but we did quadratic formula. And if you want more, 26 to 28. Those are going to be two separate documents that will be scanned and posted. One thing that I want to tell you, if you ever see state exact values, I don't know if you remember from intro to applied, like stating exact values, don't worry about it. Always turn it into a decimal and round to 2 decimals. You don't have to state anything in brutes. You just figure out the decimal, right?